Hello, everyone. Welcome to Distance Learning. Please let me know if you have any questions by either attending office hours or sending me an email. Our first lesson is going to just be a review of what we've already learned before diving into more material. So this is going to be a review of lectures 1 through 3. I recommend having out a sheet of paper or something to write on so that you can participate in the review problems and so that you have something to write on when we get to your practice problems. Here are the topics that we are going to review in that order. So starting with scalar versus vector. So here's a review on the definitions that scalar is a quantity fully described by a magnitude. So saying like 5 meters or 20 degrees Celsius, like two of the examples that are shown below. A vector is a quantity described by magnitude as well as direction. So 30 meters per second east, by having the east there, that makes it a vector, versus a scalar would just be 30 meters per second. Now your turn for some examples. Next up is a review on distance and displacement. Distance is a scalar quantity, and it is how much overall length was traveled or how much ground was covered during one motion. Displacement is just the distance between the very start and ending position. So not counting all of the different lengths traveled in between the starting and ending spots. Both of them are measured the same way in units of length. The standard unit of length is the meter, and you will see kilometers, millimeters, centimeters, anything on the metric scale for distance and displacement. Here's an example. Some of you guys might remember this one. If you are driving on a circular track that is 100 meters, going around once, your distance will be 100 meters. Going around the track twice, your distance will be 200 meters. However, your displacement, no matter if you go around the track once or twice, will be 0 because you are starting and ending at the exact same spot. Here's an example of distance and displacement on a number line. So the object travels from A to B to C. To determine the overall distance, we are looking at the orange lines. So going from A to B and then adding that to the B to C distance for a total of 18. But the displacement is just the distance between the start, which is A, and the end, which is C, which is 10. We also did distance and displacement calculations with vector mapping. So in the green, you see the vectors drawn out that show where Jeff ran. To determine the total distance, we just added those 3 vectors together. Then determining the displacement, we needed to use the Pythagorean theorem and draw a triangle so that the hypotenuse is the displacement, so going from the start to the ending spot. And plug the different sides of the triangle in and solve for C, which is your hypotenuse. Now it is your turn for some distance and displacement problems. Here is another. Mrs. Hilt, me, ran 6 miles west, then 2 miles north, then another 2 miles west. Identify the correctly drawn vector map from the options shown below. D was the correct answer. Now determine the distance. Finally, determine the displacement. And I drew in your displacement or your hypotenuse to make it a little easier for determining the sides of your triangle. All right, the next review topics are speed and velocity. So speed is how fast something is going, and this is a scalar quantity because it is just about how fast you are moving. It doesn't talk about the direction. Velocity is both the magnitude and direction, therefore it is a vector. And how you will calculate both of these actually is taking the displacement divided by time. So the units are always going to be some type of distance or displacement over time, such as meters per second. When velocity is positive, that means that an object is moving in the forward direction. A negative velocity means that something is moving in the backward direction, and zero, something is not moving at all. Here's an example of calculating velocity. So taking the distance divided by the time, and the answer that is boxed is the rounded answer with the correct number of significant figures. Now it is your turn. One more speed and velocity problem. For the graphs shown below, identify what the velocity is for each of them. All right, our last review topic is dimensional analysis, specifically with units on top and bottom. So you guys have seen this picture a few times now from first trimester and when we went over this lecture. But remember that whatever unit you are trying to cancel out, you must put in the denominator. So if you are, whatever your given value is, that unit also has to go in the denominator, and that continues on. That same rule applies for canceling out units in the numerator. If a number started in the denominator, you cancel it out with that same unit written in the numerator. And how you cancel things out is by using different conversion factors. Here's an example. I took this picture before we left for break. So first one, converting miles per hour into meters per second. And remember that it doesn't matter where in the dimensional analysis setup each conversion factor goes. The key part is just having the units canceling out the proper units. So for example, see hours right here is canceled out way down the line with an hour up here. It's okay that there's two conversion factors in between. The important part is that we have hour here, so they cancel out. Now it is your turn to practice some dimensional analysis calculations. You guys will go through 3 different calculations, and all of the conversion factors that you will need are provided here. Thanks for watching the video, and if you need to redo the video to earn at least an 80% or higher, which will earn you full points, please send me an email and I will reset your progress. You'll have 1 week from when the video is posted to complete any redos for more points. Thanks for watching.